recordings from the calendar. So that is something you can do for the safe side. Okay. And if you are talking about the sheet, we will create one sheet and upload on the portal under supplementary content. Okay. But till then, what you can do, you can access from the calendar. Once you will click on your calendar of stats 2 course, you can find the link there. Okay, let me show once. Let me share my screen. I will show you how to access. Suppose, is my screen visible to all of you?
No, no, sir.
Now,
Yes,
yes.
right, sir.
Now it's visible. Okay,
Yeah.
suppose last session was on Saturday. Let's say this first session. So what you can do, just click there. So there is something. No, if you will click, this is the recorded video. Okay, so you can find from here. And do not try to take this. This is not a PDF. This is just a attendance list. Okay, so if you will click, if you will ask access for this, so it's no meaningless. So just try to take the excess of recording we will provide from our side. Okay, and if you are talking about sheet, don't worry, we will provide that also. Okay, so let's start the session. Let's start the technical things. Okay, is my this PDF is visible to all of you?
Yes, sir.
Yes,
Oh,
sir.
Yes,
okay,
sir. Yes.
all right, great. Yeah, thanks for the confirmation. Okay, so in stats 1, you have seen something about, right, what is the discrete random variable, right?
Yes,
Correct.
sir.
And
Which
Yes,
can
sir.
take any value.
correct. So if you have discrete random variable, so that variable will take something, countable values, correct? And that
Yes.
discrete variable will have PMF, which PMF stands for, it's called probability
Mass
mass
function.
mass function, right? That is something you are aware about. So what probability mass function tells us? So, okay, anyone, any idea what is the probability mass function? That's something which you have learned already. Can you tell me what is the probability mass function?
The sum of all probability will be 1, sir.
That is the property. I'm just asking,
Sir,
what do you mean
it's
by
a
PMF?
distribution of
Probability associated with
probabilities.
each element entries.
Okay, anybody else?
Every
PMF is
individual
a
element
function
have its own
that
probability.
assign the probability from the sample space to 0 to 1, sir.
Okay, correct. So I'm not saying everyone is wrong. I just wanted to listen the what like something. What do you mean? I mean, it's a layman term. I mean, in layman term, how will you explain someone what is the probability mass function?
Summation of the probabilities of that function.
It's basically the probability of the function across its entire range.
Okay, yeah, okay, yeah, correct, correct. Now, so let me explain once. So, what is suppose x is your discrete random variable, okay? And let's say it's taking some countable values. So x1, x2, let's say xn. So it can be countable finite or countably infinite also, right? But it should be countable. So what is the probability mass function tells us? So let's say, so you are interested in to know the probabilistic behavior at each values of x. Okay, so let's say what I'm saying. So suppose x is taking value x1, then what is the probability of taking this value x1? Let's say p1. Then what is the probabilistic behavior of random variable x taking value x2? Let's say this is p2 up to pn. Okay, and what is the two key property for being a valid PMF? This probability should be between 0 and 1, correct? And second property was summation of all the probabilities should be equal to 1. Would you agree with me?
Yes,
Yes,
sir.
sir.
Yeah. So this will
Yes, sir.
tell you, this PMF will tell you the probabilistic behavior at each values of your x. Okay, what is this x1, x2, xn? Can I say this is, let's say I'm going to denote with tx. So can I say this x1 up to xn, this is the range of my random variable x?
Yes, sir. This is the
Yes, sir.
range of sample space.
This about your random variable.
Random variable.
No, so
Hmm.
this was something which you have seen, and you have seen something, how to calculate probability. Let's say x less or equal to x3, correct? This is something you have seen, and probability that x is less or equal to x3, given that x is greater than x2. This is something you have already seen. Yes or no? Any
Hmm.
doubt in this?
Yes, sir. Absolutely.
No?
Yes, sir.
Okay, great. So now this is something which you have learned just about one random variable. What if you have two random variable? Okay. then how will you proceed in case of two discrete random variables? So all the property will be same, but the only thing is this for two random variable it will be extension of as compared to one random variable. Now let me proceed. Suppose, okay, so I will not write the full definition. Okay, I will just give you the some idea. Okay, so suppose you have, or would you like to me I should write whole definition? Suppose your x and y are discrete random variables. So I'm writing this. Sometimes I will write DRV just for time saving. So DRV stands for discrete random. This is not any standard notation, just for our simplicity. So suppose x and y, these two are discrete random variable, and both are defined in the same probability space. Now let's say Tx represents the range of x. Okay, there is some background noise. Can you mute yourself, please? Whenever you are down, you can unmute. And let's say Ty represents the range of my random variable y. Okay, now so I'm going to define the joint probability mass function. Okay, so joint probability mass function. So for one random variable, it's just a PMF. For two random variable, it will be joint mass function. How you can define? So this is something notation fxy. I will write. So here you can write T1 comma T2. I will explain the notation. So this stands for this. This means what is the meaning of this? So this means probability that x is taking value T1 and y is taking value T2. Or else you can simply write x equal to T1 comma y equal to T2, and you can say T1 belongs to this is the range of x, and T2 is the one of the value from range of the y. So far so good. Any doubt?
No, sir.
Okay. So how to proceed actually? So I will draw a one small table, 2 cross 2 table. So let's say I'm just making a notation of, let's say this is T1 and T2. Okay, and say let's say this is, I'm just assuming x1 is taking value 0 and 1, and y is taking value 0 and 1. Okay, so how will you make the joint PMF table? Okay, so let me say, okay, let me take one example, very simple example, which is called tossing a fair coin. Okay, so since, okay, if you have one random variable, if I will say you have to toss a coin single time, so what is the possible values your x will take?
Head or tail?
Head or tail? Let's say head I'm going to denote as a 1 and tail for 0. And let's say your coin is fair coin or unbiased coin, then what will the probability?
1 by 2.
1 by 2.
1 by 2 for each case, right? Now, if you are going to toss a coin, let's say, I'm saying toss a coin twice. So let's say toss a fair coin. So fair means there is no bias. There is, I mean, it's unbiased coin. Okay. So if you are going to toss a fair coin twice, okay. So if I'm saying, okay, so let's try to fill this case. If I'm saying x1 is taking value 0 and y is taking value 0. Okay, first of all, let me define my random variable xi will take 1 if ith toss is head, and it will take value 0 if ith toss is tail. Okay, let me, so it's a ith toss, or you can say ith, here ith toss. Now what do you mean by this? How will you interpret this? So this means I'm interested to know the probability that in the first toss, okay, let's say if here I denoted as xi, so let's say this is x1 x2. Is the notation clear to all of you? You can write x1
Yes,
x2 or xy, right?
Yes.
So let's say I'm saying x1 is 0, x2 is 0, then what do you mean?
Both are
Both
There is
lines
Both are tail, right?
tail.
What is the probability in that case? It's a
1 by 2.
1 by 2 into 1 by 2.
That is 1 by 4,
1 by 4.
correct? One second. Okay. Now, so this will be 1 by 4, right? If I'm saying, let's try to fill this one. So what do you mean by, how will you interpret? This means T1 that means x1 is taking value 1 and x2 is taking value 0 to fill this entity? Yes or no? This means I'm interested.
Yes, sir.
X1 is 1, x2 is 0.
Hello,
Again
sir.
1 by 2 into 1 by 2.
Hello,
Yes.
sir.
1/4.
Sir, can you hear me?
Yeah.
Sir, I have to ask you a little bit confusion between when we used to plus and multiplication. I don't understand sometimes.
I
I
will come
used
to that. Okay, that depend on the
no,
scenario.
sir. 1/2 and 1/2 when we have to
So
multiply and when
this
we
is
have
independent trial, right? Something you have
yes,
learned in stats one, right? If
yes, sir,
you
yes,
are saying, uh, how will you say probability A intersection B when A and B are independent? This means probability of A into probability of B, right?
yes.
Yes.
The same thing we are doing, correct? So if you are
Sir,
talking
A
about,
into P of B.
sorry, and if you have disjoint event means there is nothing common. I mean intersection between A and B
Then P
null.
of A plus P of B.
Then by the addition rule of probability, I will say probability of A union B is relatively P of A plus P of B minus probability of A intersection B. But in this case, this will be 0
No.
when A and B are disjoint. So you have to add.
No
Okay. So
common point in between them.
correct. So these two events are independent. Okay. Now
It means that when they are independent, then we have to multiply. That's simple.
correct. So it's a and procedure, right? I'm saying x1 taking its value 0 and x2 is taking value 0. So whenever and is there, independent there, you can multiply. Okay.
Okay, thank
Yeah.
you.
And in this case, again 1 by 4. Would you agree with me, all of you?
Yes, sir.
Yes, sir.
Yes.
And again, this is
1/4.
1 by 4.
1
Okay.
by 4.
So you can see, and what was the property in case of single random variable for being a valid PMF? All the probabilities are
Summation
between,
Will come up to 1.
all the probabilities are first property. All the probabilities are between 0 and 1.
Yes, sir.
Okay. Which you can verify here. All the entries are between 0 and 1. Yes or no?
Yes,
Yes,
sir.
sir.
Yes,
And
sir.
second property was summation of all the probability should be equal to 1 in case
Is
of
equal
single
to
random
1.
variable. The same property is going to apply here, and you can see 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4, which is 4 by 4, which is going to equal to 1. So that is something called, this is the valid joint probability mass function.
Function.
Okay. In case, suppose, in case, suppose this is unknown to you. Okay. Then how you can proceed? You know, summation of all the probabilities should be equal to 1.
Yes, sir.
Correct? Then how will
Yes,
you do?
sir.
You will do k plus 1 plus 1 by 4 plus 1 by 4 plus 1 by 4. This all probability should be equal to 1. Sorry, 1.
1. Yes, sir.
Right? So from here, k will be 1 minus
1 minus 3 by
3 by
4.
4, which
1
is,
by
1 by
1
okay.
by 4.
So if there is any unknown quantity, then how you can proceed? Basically, you can apply the concept of, you can apply the properties of valid probability mass function. Is this clear? Any doubt till now?
Yes, sir. It's clear,
Yes, sir.
sir.
Okay. Now, so next topic is called marginal probability mass function. Okay, it's called marginal PMF. Okay. So before going to technical definition of marginal probability mass function, all of you have seen something in week 4 of stats 1 course. Let me draw that and then I will proceed how to. Okay, suppose there is uh, criteria of let's say gender, and there is you are going to test for some disease. Okay, so let's say there is two possibility whether disease is positive or negative, and let's say we are taking the two uh, possibility of gender, female and male, and let's say this is 0.3. This is the relative frequency is given to you, and let's say this is 0.2, and this is suppose 0.25, and let's say 0.25. Okay, now suppose let's keep it this case. Suppose I will ask, what is the uh, like proportion of female or probability of female?
0.5.
0.5.
Okay, how did you find? You
Sum
simply
over the
By
inequality of
adding
you
first
simply
probability.
added this case or this case, right?
Female row.
Correct. If I will ask for male
0.5.
0.5, which is
0.5.
addition of this case or this case, right? If I will ask probability of or proportion of positive cases,
0.55.
0.5.
0.55.
that means you have added this case or this case, that is 0.55, and this will be point.
0.45.
Okay. Now the similar concept, this is the same concept which you are going to use for marginal probability mass function. I will take one example, then I will come to the technical definition. Okay, so let's say this is my x1 and this is my x2. Okay, and I will take that coin toss example. Okay, let's say 0 1 0 1, this is 1 by 4, 1 by 4, and 1 by 4, 1 by 4, and this is the case. And let me write here, so this will, can I say this is going to represent fx2, I mean PMF of x2 means this case and this case, yes or no?
Yes, yes, sure.
Okay,
Okay.
so the thing is,
Yes, sir.
if I will ask what is the value of fx2 1. Okay, let me rewrite here. If I will ask, tell me the value of fx2 1. That means what? Oh, let's do first of all fx2 of 0. This means what?
1 by 4 plus 1 by
1 by
4.
4 plus 1 by 4.
This I'm going to add this case plus this case, which is
Yes,
Yes.
sir.
2 by 4, or I will say half.
Yes.
Yes or no?
Yes, sir.
Yes.
Yes, sir.
If I will ask, this means what? What is the happening here? What is the happening? So this is what? Can you say this is fx1 x2 0 comma 0?
Yes, sir.
Yes, sir.
Yes,
And
sir.
this is
Yes,
what?
sir.
Yes, sir.
F of 1 comma 0,
Yes.
Yes,
Yes,
sir.
sir.
right? So this is, if I'm interested only in this row, right? First row. So what is happening? I'm going to add fx1 x2. X2 is 0 fixed, right?
Yes.
Correct. X1 x2, this is 0. I'm interested in this row. What is the case? X1 is varying, so I will add this probability, and x1 is when x1 is taking value 1. Is this clear? And this is
Yes.
1 by 4 plus 1 by 4, which is half. Correct. Now,
Yes, sir.
if I will ask fx2 of 1, that means what? Let's say fx1 x1 x2. This is 1. This is value for x2, right?
Yes,
And
sir.
fx1 x2, this is 1.
1.
So what you have to do, basically you have to add all the possibilities. I mean, we have to do the summation of all the possible values of another random variable. And what is in this case, you have x1 is taking value 0,
0,
and
comma 1, 1,
again
comma 1.
again it will be 1 by 4, 1 by 4 half. Correct?
Yes.
Are you getting my point, right? So let me use some other color. If I want to calculate fx1 0, this means what? So fx1
1 by 4
x2,
plus
so
1 by
this means
Hmm.
I have to
Yes,
add
sir.
this column, right?
Hmm.
This means in this
1
case,
by
first
4
of
by
all,
1 by 4.
for x1 0 is fixed, and this is fx1 x2 0 is fixed. So you can see for x2 I have to add 0, and
0 and 1.
again it will be half. Yes or no? So this is
Yes, sir.
fx1, let's say t1. Okay. So t1 in general, and this is particular value, right? And again this will be half. So basically here fx1 of 1 again will be half. So this is called marginal probability mass function actually. So if I will write, if I will write in general, I mean general definition. So I should write fx t1. Okay, this means I'm interested to know probability that x equal to t1. So in this case, what you have to do, you have to add fxy. Okay, let's say t1 t2 plus fxy t1. Okay, so this is for x1 x2, and let's say in case of y there is some other values. Okay, So let me write in general. So let's say this is T2 dash or something else, right? So if I should write in general, so what should I write? So I have to do summation over where T2 belongs to Ty. Is this clear? Any doubt?
Yes, sir. Yes, sir. No, sir.
Okay. So this is called marginal PMF of X. If
FX.
I will say Fy of T2, this means, okay, here you can see. So Y or you can take X2. Let's take X2 if you are getting confusion. So let's say X2. Y is okay, or should I take X2?
Whatever you take, sir.
Okay, I mean notation is clear, right? So do let me know if any point, if you are facing any difference. So this means you are interested to calculate probability when Y is taking value T2. So this means you have to do, you have to add the joint probabilities. Okay, so here summation will be for the range of.
EX.
Is this clear?
Sir, that means, sir, why Y is taking value to T2 and all the respective value of X.
Then in this case, this T1 will be fixed. You have to sum over all the possible values of Y.
मतलब कि सर Y की T1 T2 वैल्यू फिक्स रहेगा, बाकी X की वैल्यू वेरी करेगा यहाँ पे.
X का फिक्स रहेगा, Y का वेरी. Okay, let me take one example. Let me take. Suppose I'm saying Ty is something Y1, Y2, let's say Yk. Okay. So okay, fine. So I'm saying range of Y is this case. Okay. So what I mean, if I have to calculate for X equal to T, so this means I have to add all the cases when X is taking value T and Y will take value Y1, or X will take T, Y equal to Y2, right? Or X T, Y equal to Y3, and so on. X is will take value T and Y equal to Yk. Is this clear? So thing is, if I will say probability X equal to T, so probability that X equal to T, Y equal to Y1, plus probability that X equal to taking value T and Y equal to Y2, plus so on. You can say probability X equal to T, comma Y equal to Yk. So what is happening here? So you are, if you see, this is fixed. You are interested to calculate the marginal PMF of X when it's taking value T, but you have to do the summation for all over the different values of Y. So this is summation of joint probability. So I will say probability X equal to T and Y equal to, let's say I'm saying Yi, and this I is nothing but range of Y. Is this clear now?
Yes, sir.
Okay.
Yes, sir.
Any doubt?
Yes, sir. Clear.
Okay.
Basically below the summation, we'll have to take that value which is, which is continuously changing. Basically, say for example,
correct, right. So okay, you can understand from this example. So if you are interested only in this case for female, anyway, so this is the categorical variable. I just took this example to give you an idea. So if you are going to take the probability of being a female, then in that case, what you are adding? You are adding for female this possibility of being disease, positive and negative, right?
Yes.
Only then you are getting. So suppose I'm interested to know fx2 of 0, right? I'm interested to know fx2 of 0. Then in that case, what is happening? So you are adding when x1 is taking value 0, this probability when x1 is taking value 1. Only then you are getting this value, right?
Yes.
Right. So
Yes,
okay,
sir.
let me make one table again. Let's say, so this is x1, this is x2. Let's say this is taking value 0 and 1, 0 and 1. So what is this case? So this will give you probability. I'm writing x1, x2, 0, 0.
Yes, sir.
This is f1, x1, x2. This is
0,
1,
1.
0, 1 or 1, 0?
0, 1.
0, 1.
1, 0, right? Because
It's 1,
here I denoted
1, 0, x1.
I denoted x1 as a first. Okay.
Okay, x1.
Yes,
Correct.
sir.
1,
And this is x1, x2. This is 0,
0,1.
0,1.
this is x1, x2. This is
1.
1,1.
1,
okay. If you need this case, okay. So this is okay. This is what? fx1, x2, 0, 0 plus fx1, x2, 1, 0. Right? In this case, what you will get? You are getting this is fx2 of 0, right? This whole quantity, right? Are
Yes,
you
sir.
getting my
Keeping
point?
the
Yes,
1
sir.
constant and then we're just summing over the.
So yeah, correct. So this is what I am interested. Okay, first of all, this is fx2 of 0, right? And this row will give you fx2 of 1.
Yes, sir.
So
Yes,
you can
sir.
see for x2, this is fixed, right?
Yes,
And
sir.
I'm
Yes, sir. It's
adding
constant.
for
Yeah.
all different values of x1.
Yes, all
X1.
the possibilities over X.
Correct?
Sir,
X1.
Is
I
this clear
didn't
now?
get that, sir.
Sorry?
I didn't get that how fx2 come and it's 0.
No, no. So this okay. First of all, is this clear? This x2 is taking value two values, 0 and 1. Okay.
Yes, sir.
If you want to calculate this when x2 is taking value 0, then how will you do? Tell me.
Repeat, sir, please. I didn't know.
Okay. So this is 0, 1, 0, 1. This is x1, x2. If I'm saying this is 1 by 4, 1 by 4. Okay. And this is 1 by 4, 1 by 4. If I will ask what is the probability x2 is taking value 0, then how will you do? What you will do
Sir,
first?
1 by 4, 1 by 4, 1 into 1 by 4.
Why into?
No, sir.
I'm asking
So
x2.
plus dependent variable.
So this is 1 by 4 plus 1 by 4. You are adding the first two, right? You are adding all the entries in the first row.
Yes.
Okay. The same thing I'm doing, right? So x2 is fixed. This row will give me. I'm interested to know the probability that x2 is 0, right? So I have to add this entry plus this entry. The same thing I did, right? Now
Okay,
in
sir.
that case, this is 1 by 4. This is 1 by 4. That's all. So you can see x2 is fixed. Okay. In this row, what is fixed? First of all, let's start
0,
with
0.
0, right? What is varying? It is varying
Uh,
this case, right?
0,
0
yes, sir.
One is
and for
varying.
x1, this is 1, right? So I have to add these two possibilities. That's all.
Okay, sir. Got it.
Okay. In the second row, what is the fix? This 1 is fixed,
1.
right?
One
Okay.
is
What
fixed.
is varying? You do this 0 for x1 and 1, right? So this will be x1, x2, 0, 1 plus x1, x2, 1, 1. Is this clear?
Yes, sir.
Now, if you see column wise, okay. Let me use some other color. So what is fixed here in this column?
x1.
x1, 0.
0 is fixed, right? So this will give you fx1 of t1, right? So 0 is fixed, right? So what is varying?
x2 is varying.
0, 1.
So this is for x1, 0 is fixed. I have to add this entry plus fx1, x2, 0, 1. Would you agree with me?
Yes, sir.
Yes, sir.
Yes, sir.
And in the second column, what is the fix? When x1 is taking
1.
value 1, you can see, right?
1.
I have to add these two entries. So this is fx1, x2, 1, 0 plus fx1, x2, 1, 1. Any doubt? Now, and
No.
if you will add these two values, this plus this or this plus this, at the end, you should get
One.
the grand total as a 1.
1.
Okay. Marginal PMF is clear to all of you?
Yes, sir.
Yes.
Yes.
Yes, sir.
Now, let's talk about conditional. Okay, conditional distribution of one random variable given another. So, before going to before going to in terms of random variable, I will start from the event, which is something you have learned in Stats 1 course. How many of you can recall from Stats 1 course?
Yes, sir. Yes, sir.
Somehow 70% of the syllabus.
Yeah, everything is fine. So just
Of x such that y equal to
Bias theorem, sir.
no Bayes theorem. Bayes theorem is just
No, sir. Are we talking about the conditional probability?
yeah conditional.
Probability of
Okay,
A
suppose I'm
intersection
saying
B.
Okay, let's say we have
A intersection B बराबर P A condition B equal to P A intersection B by P of A.
Sir, conditional distribution is nothing but the product of joint and marginal.
Yeah, correct. So that is another form. That's not a wrong. Okay, let me explain. Suppose I'm saying I have two events A and B. Okay, so okay, let me give you idea from where this formula came. Suppose I have two events. This is A and this is B. Okay, so this is B. This is A. Now I'm saying I'm interested to know what is the probability that A given B. Okay, so I'm saying B is given. That means B has already occurred. Yes or no?
Yes, sir.
Yes.
That means this green shaded region is already occurred.
Yes.
Yes, sir.
Okay.
Yes, sir.
Now I'm asking, my question is, I'm saying what is the probability that B is already occurred? What is the probability of being happening A when B is already occurred? So what is the probability of happening A when this green part is already occurred? What is the probability of happening A? This
Probability of A intersection
Probability of
B.
intersection B
this
upon
this this
Probability
red
of
region.
probability of B.
Would you agree with me or not?
Yes,
So
sir.
this red shaded
Yes,
region
Yes, sir.
is the probability of happening A when give green part is given already, right? Yes or no?
Yes,
Yes.
sir.
yes,
Right.
Yes.
And what
yes,
is the red part? This is
A
the
inter-
intersection
A
part.
intersection.
A intersection B.
And what is the green part?
Only B.
probability of B.
Probability of B. Only B.
Probability of B. This
B.
is the conditional formula. Okay, so you can think from the basic formula of probability. What is that? Favorable case divided by total case. So now what is your total case here? The green one, right? When you can say you can consider as a new sample space. Okay, when I'm saying B event B is already occurred, you can consider as a new sample space which is of a green region, which is my new total case. And in that particular green region, what is the probability of happening A, which is A intersection B, which is red? Is this formula clear? This is conditional event of A and B.
Here,
Yes or
sir,
no?
not here, not
Yes, sir.
talking about entire region of A, only green region of A.
Yeah, that is a new sample space, right? That
Okay.
means I'm saying B has already occurred. You had
Yeah.
okay. What you will do basically? How will you find this probability A intersection B? You will do number of events occurring in A intersection B divided by S, right? And you
Yes,
will
sir.
do B and this. Okay. So at the end something will cancel. Okay.
Yeah, yes.
I'm not going into the derivation. I'm just giving you some rough idea. Okay.
No, just we are understanding in logical way.
Correct. Now is this clear, right? So I'm saying green region is already with you. What is the probability of happening in the green region, right?
Green.
Which
Yes,
is
sir.
this red
Green.
divided by this, correct?
Yeah,
Now
got it.
from this formula, can I multiply this part into the left hand side?
Yes, sir.
So what I will get? Probability of A given B into probability of B equal to probability of A intersection B. Yes or no? So I will say probability of A
Yes, sir.
intersection B is nothing but probability of A given B into probability of B, right? So this is something called multiplication rule in terms of which we have learned in stats 1. Now there will be another name for this when we will talk about in terms of random variable. I will come to that. Now can I do the same thing in reverse order also? I mean, if I will write probability B given A, again it's
Yes,
a
sir.
A intersection B
B.
divided by probability of A.
A.
Okay. Now, if this is the case, can I write here probability of A given, intersection B is nothing but probability of B given A.
Given A.
Probability of A. Any
Yes.
doubt in these two formula?
No, sir.
Okay. Now, that is not in this week 1, which is going to be in week 2, but I'm going to give you idea in this week itself so that you shouldn't worry about in week 2. Now, what is the concept of independence? How will you say two things are independent?
So
Then
the
they are not
intersection B equal to
We have
TA into TB.
One second. I just want to listen layman term, like
Hmm.
no mathematical formula. You can just think, okay, how will you say, suppose there are two person and both
Both the events are not dependent on each other, but does not affect the occurring of
Their
the.
intersection is 0.
Means, sir, happening of
One
one
agent
event does
cannot
not
affect
affect
other.
the happening of another event.
One event cannot affect the
correct, correct,
happening of
correct,
other event.
correct. Suppose let's try to understand with the very basic example, coin toss.
मतलब कि
Okay?
सर एक इवेंट का होना दूसरे पे नहीं निर्भर करता है
Correct.
कभी
That is something independence, right? Like suppose you can say, suppose two person. Okay, who told the definition of happening doesn't affect the happening or
Yes, sir.
non-happening?
I told you.
What's your good name?
Lux.
Yeah, Lux. So suppose Lux and let's say there is another person, Divyansu, right? Or Divyans.
Yes, sir. I
Yeah.
Dibbo
Okay.
Majumdar.
Yeah. Sorry. Okay. Yeah. So when you will say you two are independent person.
So
there
like
is-
in the toss of a coin, if a head is a head and tail, no, sir, they are dependent.
No. In
Sir,
coin toss example, suppose you have fair coin, right?
yes,
So
sir.
suppose I toss coin first time and
Yes,
I
sir.
got head or tail, right? And
Yes,
I'm
sir.
going to toss the same unbiased coin second time. So
Yes,
it
sir.
doesn't depend the what is happened in the first case, right?
Yes, sir. Yes, sir.
Right, first toss. So similarly, you can think about rolling a die, fair die. I mean, you roll once and you got, let's say, 2. And if you're going to roll again, then it doesn't depend on the first previous result. Independence means basically happening or non-happening doesn't affect the happening of the first event. Let's say I will say probability of A. I mean, if probability of A is equal to probability of A given B, I mean B is happening or B is not happening. Is this clear? So this is meaning of independence,
Yes, sir.
right? Same in case of another event, I will say, right? I'm saying A is occurring and probability of B A is not occurring, right? So what you can write here, I can write A given B as a probability of A or not from here.
Sir, can you explain the independence from Venn diagram, sir?
We'll come to that. Okay. So is this clear? Now can I write probability of A given B as this probability of A into probability of B?
Yes, sir.
Okay. So that is the
Yes, yes.
independence. Here again, probability of B given A will be probability of B and probability of A. Okay. Now let me talk about in terms of random variable, because see independence will come in week 2. Don't worry about that. Okay. I just
Sir, hello, sir.
gave you some
Hello,
idea.
sir.
Yeah.
Hello, sir. Can you please explain the part in which you have written probability of B given A as probability of B with the help of an example?
We'll come to that. Okay, so actually I took just this example just to give an idea. We'll see with this. Okay, as of now, anyway. So this is topic from week 2. Okay, as of now, I'm just proceeding with week 1. Okay, I will come to that at the end. Don't worry. Okay.
Okay, sir.
Okay.
Okay,
Yeah.
sir. Yes.
So okay, first of all, tell me these two things are clear to all of you? Yes. No.
Yes, sir.
Yes, sir.
All right.
Yes.
If this is clear, so this is something called, if you will talk about in terms of random variable. So you had two random variables, x and y, and let's say tx is represents the range of x, and ty is going to represent the range of y. Okay. So suppose I'm interested to calculate what is the probability that, let's say, x is taking value t1 given that y is equal to t2. The something which you have seen, probability of A given B, A intersection B. Let me write the both formula. We saw probability of A given B is nothing but what? Probability of A intersection B divided by probability of B. And from here, I can write probability of A intersection B is equal to probability of A given B into probability of B. Yes or no?
Yes, sir.
Now, by using the same concept, can I say probability of x equal to t1, and so intersection means and, right? Y equal to t2 divided by probability of y equal to t2.
Yes.
So far it is clear.
Yeah. Yes, sir.
Yes, sir.
You can relate this as this is as a and this you can b. Now is this fine?
Yes, sir.
Now can I write from here, this is called conditional probability mass function. Can I write from here probability that x equal to t1 given that y equal to t2 into probability y equal to t2 equal to probability of x equal to t1 and y equal to t2.
Yes, sir.
Yes, sir.
Right? And just change the side. So x equal to t1 and y equal to t2 equal to probability of x equal to t1 given that y equal to t2 into probability that y equal to t2.
Yes, sir.
Right?
Yes,
Is
sir.
this fine? So what is this? This is joint probability
Joint
Yes,
PMF.
sir.
and this is conditional.
Conditional probability.
Conditional probability.
Into marginal.
And what is this?
Marginal.
Marginal.
Marginal. Okay. Now is this fine? So you can say joint PMF is equal to, okay, this conditional into marginal. Okay. The thing is, which you should understand from this equation. Let's say, I mean, it's a very basic thing. If you have two known quantity and one unknown, you can calculate from where. Let's say you have been given conditional
Yes, sir.
and marginal. Okay. And I mean, let's say I didn't give you the joint PMF table, and I asked to calculate the joint PMF, and in that particular scenario, suppose conditional is given to you, marginal is given to you, you can calculate the joint PMF,
Yes,
correct?
sir. Yes, sir.
And let's say you have been given joint PMF and marginal, you can calculate the conditional.
Yes, sir.
Yes, sir.
In other way,
Sir,
right?
can you do the example of this?
Yeah, I will take. Don't worry. Okay, that's not a problem. Okay, let me take one example to proceed for the this calculation part. Okay, let me use the next page. Okay, so suppose this is t1. I mean, for first random variable, let's say x1, and let's say this is 0, 1, 2, and this is 0, 1. Okay, and suppose this is 1 by 8. 1 by 8, which is 2 by 8, let's say 3 by 8, 4 by 8, 4 to 6 to 8. I think it's 1, right? Can you check?
Yes, sir, it's one.
Summation is summation.
Yes, sir, it's one.
Yeah, this is valid joint PMF. And this will represent fx2 of t2. Right? You
Yes,
can
sir.
see this is 1 by 2. 1 by 2. You can cross check.
Yes, sir.
And this is 2 by 8, 1 by 8. This is 3 by 8. This is 2 by 8. And again, this is going to be 3 by 8. And
3 by
grand
8.
total is 1. Okay. Now here, if I will ask, what is the range of x?
0, 1, 2.
0, 1, 2.
Correct? What is the range of y?
0, 1.
0 and 1.
0 and 1.
Oh, okay, very good, very good. Now my question is, what is the let's say fy? Okay, first of all, is this clear? Notation is clear. I can write this as a fx1, x2, t1, comma t2, right?
Yes,
And
sir.
this part I can write fx1. What should I write? I can write fx1 given that x2 is equal to t2, and in the bracket it should be
T1.
t1,
T1.
and this is fx2, t2.
T2.
Right? Okay.
Yes.
Now, I mean, why I wrote like this, so that you should know how to interpret the notation. So suppose I'm writing y given x equal to 0 and 0. First of all, let's try to understand the meaning of this. So this means what? Probability that x is taking, no. What is the probability that y will take
Y 0 and X is
0,
0.
given that x is 0?
is 0.
Right? Is the
Multiplied
notation
by-
clear?
Yes, sir.
Yes,
This
sir.
is what? It should be x equal to 0 and y equal to 0 divided by probability that x equal to
X
0.
equal to 0.
0.
Are you getting how I wrote this equation?
Yes, sir.
Yes, sir.
Yes, sir.
So from the table, can you tell me x equal to 0 and y equal to 0, which values I should take?
1 by 4.
This 1 by 4. All right.
4.
Now, what is the meaning of x equal to 0? That means I have to add
1
this
by 4
entry
plus
plus this entry,
1 by 8.
which is
3
3 by 8.
3 by 8.
3 by
Basically,
8.
3 by 8.
basically, this is fx of 0,
0.
fx of
1.
1. This is fx of
Fx of 2.
2. And this is fy of
0.
and this is fy
Zero.
of
1.
one thing I would like to mention here. So this is x2 or x. I mean, you can just change, right? So x and y means two different variable, right? I'm
Yes, sir,
hoping.
that's understood, sir.
Yeah. Okay. So in the numerator part, it will be 1 by 4.
1
In the
by 4.
denominator part, it's a 3 by
3 by
3
8.
by 8.
And just solve
3
this
by
and
8.
you will get some value, right?
Yes, sir.
Now, if I will ask, what is the meaning of, let's say, fy given x equal to 1 at, let's say this is 0 at 1. So this means what? See, you can understand from it. See, it is
P
x
of
equal to
x
0 is
equal to
given,
0, y equal to 1.
right? So you can understand from here, x equal to 0 is given, right? Now this means probability x is 0, y is taking value 1 and divide by probability x equal to 0. So from the table x is 0, y is equal to 1. That means
1 by 8.
this value, right? And again it will be 1 by 8 and this is 3 by 8 and it will be 1 by 3 will be your answer. Is this clear?
Yes, sir.
Yes, sir. Yes, sir.
Now from here you can calculate the thing, right? So suppose in case, just to give you an idea, suppose I'm saying f probability that fy given x equal to 0, 1 is 1 by 3 and probability that x equal to 0 and y is equal to 1 is 1 by 8, and my question is calculate probability x equal to 0. Okay, so how will you proceed? So we know joint PMF, right, is equal to conditional into marginal,
Into marginal.
right? So we have given conditional. What is the conditional? Fy given x equal to 0, 1,
1
and
is 1 by
what will
3.
be, sorry, this is the, no, this is not a conditional, this is the, I mean, this should be joint, here should be joint, right? So probability x equal to 0 and y equal to 1, and here it should be probability that y equal to 1 given that x equal to 0 and into probability x equal to 0, right? And you have to calculate this value. You have been given these two. You can simply substitute and you can find the values. Okay. Any doubt?
No, sir.
Okay. If I will ask one thing, what is the range of y when x is given 0? My
What,
question
sir?
is, what is the range of this case?
Sir, it's 0, 0, 0, 1, 0, 2.
0.
No.
I mean,
I'm saying what is the range of y given that x is 0?
0, 1, 2.
1, 2.
0, 1.
How 0, 1, 2?
And 1.
I'm saying
Only,
x.
only 0, sir.
No. You are not getting my
So
point.
1
My
and 2.
question is,
1 and 2.
just listen. Just see. Do not try to give the answer immediately. Just think a bit. My question is, what is the range? I'm saying x, given that x is 0, what is the range of y when x is 0? That
Sir,
means
0, 1.
Sir, 0
and 1.
0 and 1.
0 and 1, sir.
0 and 1, right? So I'm saying x is 0, that means this column is fixed, right?
Yes.
Yes, sir.
Yes,
First
sir.
column.
So x is 0,
Yes, sir.
and what's the range of y? I mean, that means 0 and 1 again, right?
Okay.
Yes, sir.
Okay,
Yes,
so
sir.
sometimes in some examples it may change. Okay, so that's why I mentioned here. Okay, you should be careful a bit sometime. Okay, all right. Any doubt?
No, sir.
No, sir.
Okay, so
No,
there was
sir.
one example in the last chat of, there is some background noise. Can you please mute? Yeah, thank you. Whenever you have doubt, you can unmute. That's not a problem. Okay, so there was one example, I think, throwing a die and then tossing a coin as many times as the, I mean, number shown on the die. So I will take that example, which is a very good example for to prove this part, right? I mean, to use the concept of joint equal to conditional into marginal. Okay, so let me write that example. That is a very good example. I will write that example and then I will try to relate with the some scenario. Okay, so let me write that example. I don't know how many of you are aware about that example. Anyway, so I will write. Suppose scenario is you have to throw a die. Okay, and suppose die is unbiased and that's fair. I mean there is no biasness, and toss a fair coin. Okay, as many times. Okay, as the number shown on die. Okay, so my question is, I'm just denoting, let x be the number shown are you getting my writing? Is it fine?
Yes, sir.
Okay, sir.
Yes, sir.
Yes, sir.
So
Absolutely.
let x represent the number shown on die, and let y be the number of heads. Okay, okay, this is fine. So x is going to represent number shown on the die, and y represents the number of heads. So what is the question is, what is the joint PMF probability mass function of your random variable x and y? Okay, so is the scenario clear to all of you?
Yes, sir.
Okay, so question is, so you see, you have to identify here in a way conditional is given to you. The only thing you have to identify, first of all, if I'm saying x, what is x representing? Number shown on the die, and since this is a fair die, unbiased die, and what, first of all, what is the possible values x can take?
Sir, 1 to 6.
0, 1, 2, 3, 4,
1
1,
5.
2,
1
3,
to
4,
6, sir.
5,
Not
6.
0.
1 to 6, right? 1, 2, 3, 4, 5, and 6, right?
That's all.
That's all. And what is the probabilities it will take for each
Head
one?
1
by
1 by
by 6
6.
each.
1 by 6.
1 by 6 for each and
1 by
every.
6, 1 by
It's
6, 1 by 6.
uniform.
Okay, in a way, I can say x is following discrete uniform
Uniform.
with the values 1, 2, 3, 4, 5, and 6. Would you agree
Yes,
with
sir.
me?
Yes,
And
Yes,
sir.
what
sir.
is
Yes,
the
sir.
PMF for fxt, which is
1
1
by
by 6
6.
for
1 by
all
6.
values of t?
1 to 6.
Less than equal to 6. 1 to 6.
Okay, till this point it's clear.
Yes,
Now,
sir.
Yes, sir.
what is the
Yes, sir.
situation? If you see, situation is, first you are throwing a die, okay, and then you are going to toss a coin as many times as the number shown on the die. That means first you roll a die. Suppose you roll a die and you got the 1, okay, and x is representing the outcome on the die. That
So
means
that
once you
means I
got the
have to
1,
toss the coin one time.
one time, right? That means, and what is the y? Y representing, y is represents
Number of
number of
heads.
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 Head.
When you will get number of head, once it is given that you have to roll a die.
Right.
Are you getting?
Yes.
Yes.
Yes,
Yes,
sir.
This
Yes,
sir.
sir.
means first
Yes.
of
Y
all you
given
roll
x
a
equal to
die.
1.
Just let me write this. Let me write. One second. Give me a second. So first thing, what you have to do, you have to roll a die or throw a die. So suppose I'm saying, first scenario, you throw a die, okay, and you got, let's say, 1. That means this is given, right? X is 1, and you have to
Y
then,
given x equal to 1.
correct. So you have to basically then you are going to toss a coin one time, and you will get some number of head. Okay,
0 and 1.
0 and 1.
0 or
G- Yes, sir.
And next situation may be, suppose you roll the die and you got, let's say, 2, outcome as 2. That means you have
I
to,
have to toss 2
correct,
times.
correct. This means you have to toss a coin 2 times, right? And in this case, you can get 0 head, 1 head, 2 head, and in each case,
Yes, sir.
possibility of getting head is half, right?
Yes,
So
sir.
this
Yes, sir.
means y given. Okay, so my question is, what will be the distribution of y given x equal to t? Are you getting?
Tossing a coin t times.
Yeah, tossing a coin t times.
Yes,
This
sir.
means, okay, so okay, first of all, for ith trial, you will get either head or
Or tail.
tail, right? That means this is a Bernoulli trial.
Yes, sir. Bernoulli trial.
And if
Yes,
you are
sir.
doing, let's say if you are doing
Repeatedly, then
anytime
there is a binomial
binomial, right?
distribution.
There is a
Yes,
binomial
sir.
binomial
Correct. So
distribution.
this will be, I'm going to write the distribution just now. I think it should be clear. This will be binomial, and number of trials should be T, and success probability is half. Is this clear? So this means,
Yes, sir. Yes, sir.
when you roll a die, you got 1. So this is y given 1. This will be binomial 1 comma half, which is basically Bernoulli, right?
Yes, sir. Yes, sir.
If y given x equal to 2, so this
So
means
binomial 2 comma 1 by
2
2.
comma half. So the scenario is you roll a die and you got 2, and you to then toss a coin twice, and in that case you can get 0 head, 1 head, 2 head, right? Is this
Yes,
clear?
sir.
So now you
Yes, sir.
can
Yes, sir.
see from this example, this is conditional, right?
Yes.
So
Yes, sir.
conditional is given to you, and this is marginal, because
Yes, sir.
I'm talking
Marginal.
about
Yes,
one
sir.
random variable. Marginal is given to you. You have to calculate the joint, and you know
So
joint.
joint equal conditional into marginal.
That's all. Yeah, correct. So if you have to calculate we know. One second. Joint PMF is equal to conditional
Into
into
marginal.
marginal, right? So I have to calculate joint, and joint was let's say fxy, and I'm just writing t comma t dash, okay, just for
Yes, sir.
no difference of the okay. So here I can write
So
y given x equal to
x
t
equal to t into
t
fx of
dash,
t.
and this is fx of t. So this is, we know this is uniform. We know this is
Marginal.
binomial, right?
Binomial.
And this is uniform
Binomial.
from the scenario.
Uniform
Marginal.
distribution.
Uniform,
And
sir.
what is the PMF for this? So this will be NCF, right? So this is T. Yeah. So what should I write?
T C T dash.
C
T dash, right?
T dash.
So t dash ct.
T
T dash
dash
ct.
No. T C T dash,
T C T dash.
and 1 by 2 raised power. So
T.
basically T dash
T dash.
represents the number of head, right?
T.
So n is total number of trial, and you know x represents the number of head. Okay, and this will be half raised power T minus,
T minus T dash.
Minus
and
T.
this will be 1 by 6 only, right? Yeah, this is this FXT, right? Uniform, just rolling a die. Yes or no? Are you getting?
Yes, sir.
Yes, sir.
So this will be TC
Yes,
T
sir.
dash, and this is half raised power T only. Okay, now tell me, what is the range of y given x equal to t? This whole thing it follows binomial, right?
So 0 to
So
t,
0
sir.
and 1.
0 to T.
0 to
Not
t.
0 and 1, 0 to t, right?
Yeah.
Okay. Okay, now the idea is clear. This funda is clear.
Yes, sir. Yes, idea is clear, sir. Absolutely clear.
So you can
Yes, sir.
calculate the joint equal. I mean, you can like it's clear, right? How to get joint. I mean, how to use joint equal to conditional into marginal, right?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. We can calculate.
Okay, all right. So there is one more.
So we have to just make the
Please
tables.
explain the range of y once.
Okay, so range of y given x equal to t, you can see this is going to follow binomial, right?
Yeah.
Yes.
Okay, so if I'm
Yes, sir.
saying x follows binomial, let's say n comma p. So what is the range of x? 0, 1 to n, right?
0 to n.
Basically, you can think. Do not, if you are not, if you don't want to remember, just think with example. So n represents the number of trials, right? So here t represents. So basically, t is number of trials. So
Yes, sir.
suppose you roll a die, you got 3. That means you have to toss a coin 3 times.
Right.
Okay.
Yes,
If
sir.
you are
3
tossing
times,
a
sir.
coin 3 times, and if you are interested in the number of heads, so it's possible, right? So in the all 3 tosses, you can get 0 head, you can get 1 head, you can get 2 head, and it's possible you can
Three.
get all heads, right? This is the
Correct.
range of x. That's all.
182838.
Right?
Yes,
This
sir.
is the range of x. That's all. Okay. There is one more derivation. If you are interested, I can do, or else we can move for more than two random variable, which is the same, just extension of two random variable. So, do you want to do me that derivation? I mean, it's.
Yes,
I
sir.
mean, this is just example of again using the this joint equal to conditional into marginal. Is this fine?
Yes,
Should
sir.
I?
Sir, yes, sir.
Derivation, sir, derivation.
Okay. Okay. Fine. 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 If you are okay with that, that's
Yes,
not.
sir. Yes, sir.
So before derivation, can you please summarize at once?
Which one?
Theory part which you have just taken.
This is the binomial case.
Yes, sir.
Okay. So you can think this is okay. Any one of you would like to explain? Anyone?
Yes, sir.
Yeah. Can you explain? Yeah.
Yes, sir.
Just tell me. I will scroll down the PDF page. Yeah.
Okay, sir.
Yeah.
So first of all, in this question, we had a condition of throwing a dice, and with on that condition, the tossing of coin was dependent, and with the numbers that we get after throwing the dice, we'll be tossing the coin. So this is the condition we are given with. So then we calculate the marginal probability of throwing a dice, which is 1/6, and with the tossing of dice, we have this binomial distribution because it's the condition that's dependent upon the number we get in die. So with the binomial expression of getting the success that we want, we can form the expression, and that's it.
Okay. Is this clear or is this
Yes,
clear
sir.
to you?
Clear, sir. Absolutely
Yes,
clear.
sir.
Yeah.
Yes,
Okay.
sir.
Okay. So do you proceed further or would you like to miss?
Yes, sir. You should
No, sir. You
proceed
can
further,
go
sir.
Yeah.
further.
Okay. All right. Yeah. Okay. So scenario is so this is just example two. Suppose I'm saying there is a one random variable n. This is follow Poisson distribution with parameter lambda. Okay. Now what is the scenario given? Let me write from the next line. Okay. Similar scenario. So suppose given capital N equal to small n. So this capital N is a random variable. Okay. If I'm saying given capital N equal to small n, then what is the next task? This is you to toss a fair coin, okay, n times. Okay. Suppose n is capital N is equal to 2, then you have to toss a fair coin 2 times. Okay. And denote the number of hits obtained by, I mean, whatever the number of hits obtained, you have to denote the by random variable x. Next question is what is the distribution of x? Okay. Now you can see here in the previous example, right? So we have been given the marginal, right? X follows x
Yes,
was
sir.
following
At this
uniform.
time, we have to find the marginal.
Marginal. And the thing is, now you have to think a bit here. We know joint PMF is equal to what? Conditional
Conditional into
to
marginal.
marginal. Now, to solve this equation, if you see marginal, we have to calculate, right? Distribution of x. Okay. Now the
Joint by
scenario is
conditional.
yeah, 1 second. So this conditional is given, right? This is given in the question, right? This given and equal to and you this is give. I mean, okay. First of all, this is given, right? So given that n equal to n, you have to toss a coin n times. So and x represents number of heads. So this is again this will follow binomial with parameter n comma half. Is this clear?
Yes, sir.
Everyone is getting this point.
Yes.
This is same as in the
Yes,
previous
sir.
one, right?
Yes, sir.
Now, so conditional is given to you. It is asking about marginal. The one thing we need to calculate joint, right? That is something which is you can say inherent in the example itself. So first of all, we need to calculate the joint, right? Yes or no? Only then you can
Yes, sir.
calculate the
Yes, sir.
marginal, right? So
Yes.
first of all, what
Yes,
is
sir.
the case? Okay, what if you can see uh, something, let's say some t, and here I will write fn of n. Can I write? Because n is given to us.
Yes, sir.
Yes,
By
sir.
using this information, I can calculate the let's say this is k and this is n. Okay, so I can calculate this joint or not. Is this clear?
Yes. We
So
can.
why I'm writing like this? Because this conditional is given to you and this marginal is given to you, right? I mean, distribution of n is given to you. You to calculate for x. But to calculate for x, let me write the formula again. If you want to calculate for x, so first of all, you need this fx of k to calculate for x. What you can do? You can go with the, okay, let me write, let me do in other way. Okay. First of all, tell me, can I calculate this joint PMF from here? Yes or no? Because this
Yes.
conditional is given to us and this capital N random variable is following Poisson distribution.
Yeah.
Okay. If you know the
Yes, sir.
joint, I can calculate the joint from here, then I can calculate the marginal of x also, right? How? Anyone, any idea? If you have been given the joint, how you can calculate the marginal?
It's conditional,
Conditional.
marginal upon condition.
No, forget about that because here we do not have in reverse order, right? Okay.
So just adding them, sir, like
Correct.
marginal.
Correct. So you have been given the joint PMF. We have discussed to calculate the margin. What we can do, we can add basically. So if okay, can I do like this fxk? I can add throughout the range of n and this joint PMF. Would you agree with me?
Yes, sir.
This is also one of the possible way.
Yeah.
Okay, you are saying conditional joint divided by conditional. That's also correct. But in that case, we need this scenario, right? But we don't have this part. Are you getting my point? We don't have this part, right? This will be fx of k. To calculate this part, we don't have this conditional probability. Yes or no? Are you getting?
Yes, sir.
Yes, sir.
So that's why we are proceeding like that. Okay. Now, so what we will do?
Sir, this question I am not get. Please repeat again.
You should tell me at the same day, right? So okay. Let me rewrite. Can I write the above equation? This is n given x equal to k n into fx of k. Okay. Can I use this two? Yes or no? These two are correct or not?
Yes, sir.
Correct. Correct.
Right. So what I'm saying, you can do the joint divided by marginal, joint divided by conditional, but this conditional part is not given to us, right? N given x equal to k. We have been given this part, x given n equal to n, right? So that's why we are not using the this joint divided by conditional. What we will do?
How can we know that it is given x given n or n given
This
x?
is given in the question, right? You can see this given n equal to n, you have to toss a fair coin n times, which is denoting the number of heads. So this is binomial only. Okay, this is given. You to, if n equal to n given, then you have to toss a coin which is going to follow the binomial distribution. So this part is given to you. I mean, it will be given in the question, right? All the entries, right? So I'm just trying to explain here why we are not using joint divided by conditional, because we have to calculate the marginal of x, not marginal of n. If in case we have to calculate marginal of n, you can simply divide, right? Are you getting my point? What
Yes, sir.
right? So what we will do?
Sir,
we
repeat
will,
one time, please.
Okay, is this formula clear? So what we will do basically, this part is this conditional is given to us in the question, right? Which is
Yes, sir.
binomial. This marginal is given to us, right? Distribution of n, which is Poisson distribution, right? So this, what is the PMF for this? E raised power minus lambda. Lambda is for
Lambda to the power k by k factorial.
n divided by n.
It has an n by n factorial, yes.
Right? And we need to calculate the marginal of x. then by using this concept, joint PMF equal to conditional into marginal, what I will do, I will calculate the joint probability mass function of x and n. And since we know to calculate the marginal of one random variable, what I will do the summation of joint probability mass function for another random variable. Yes or no?
Yes, sir.
Okay.
Sir,
Yes,
tell
sir.
me why don't we divide here, sir?
How will you divide? First of all, tell me. How will you divide? Yeah, see, don't worry. It's not like any punishment or something. You can tell me, so I will clear your doubt. So how you will divide? Whatever the something you are getting, don't worry about whether it's going to wrong or correct. This is not an exam. I will clear your doubt. So my question is, how will you do it? Why you are thinking we should divide?
Yes, it is little bit difficult, sir, to divide.
Not difficult.
So
So
values are not given. So
it's not
values are not
possible,
given.
right? It's not possible here. So question
Yes,
is,
sir.
my question is, okay, let me say, suppose I'm saying you have been given x plus y equal to 2. Can you find the values of x and y both by
No,
one
sir, we
equation?
need another
No,
equation.
no, sir.
Okay, you need one more. Okay, let me write like this. Suppose I'm saying
But
uh,
if we're going to find out x and y from this equation, we have to assume some values.
see, can you calculate the value of x and y?
No, sir. Not
No, sir.
possible.
Correct?
No.
Not
No,
possible,
sir.
right? The same thing
Yes,
is
sir.
here. Only one thing is given to you, right? Here only one thing is given to you. Conditional. You can't calculate the marginal of x by using this conditional, right? So this marginal is for n, right? Here. Are you getting my point? See, I
Yes, sir.
think
Yes,
Yes,
sir.
sir.
see, there were two equations, right? Probability of A given B, probability of A intersection B divided by probability of B, right? And there was another one, probability of B given A. I can write probability of A given intersection B divided by probability of A. Now, from here, can I write probability of A intersection B equal to probability of A given B into probability of B, right?
Yes,
Now,
sir.
Yes, sir.
from here, probability of A intersection B equal to probability of B given A into probability of A, right? Now, just think,
Yes, sir.
what is the scenario? Question is, A given B is given to you. Let's say A is probability of here x given n equal to n. This is given to you, right? And probability of n is given to you. And from you by using these two, you can calculate the joint of x and n. Yes or no?
Yes, sir.
Now, question is, you have been asked for A. Let's say A I took as for x. So you have been asked for fx of k. And we don't have fx of, sorry, here fn of x given something, right? And you have to calculate fx n of k comma n. Now, can you tell me, can you calculate fx of a by using this? Because you can calculate the joint from this part, right? But is this information given to us? No,
No, sir.
right?
Yes, sir. Yes, sir.
Are you getting my point? So you have two
Yes,
unknown
sir.
quantity. This is unknown. This is unknown. You can't calculate the value of known, right? Let's say this is 0.2. Just assume hypothetically this is 0.2. This is x. This is y. Can you calculate x value of y
No, no,
from
no, no,
here?
sir.
We can't,
Absolutely
right?
not, sir.
We can't,
Yes,
No,
sir.
right?
sir. No.
So what we will do, basically, we know one concept. I can calculate the joint from here, right?
Okay.
And we know if I'm able to calculate the joint probability mass function, then I can calculate the marginal by adding the throughout the possible values of another random variable. Correct?
Yes, sir.
Okay. Now, so
Sir,
let's
in this equation, sir,
Hmm.
so in this equation, when you say f of x of k,
Hmm.
we don't know about its distribution. Shouldn't it be binomial, sir?
It's not a binomial. Conditional is binomial. This conditional is binomial.
Yes, sir. Yes, sir.
We
Only the
don't have
condition is binomial, sir.
separate definition information about x. See, if you read the question, just try to understand the question, right? So do not think randomly. So question is, if you read this statement, so this statement says given n equal to n, right? Then you have to toss a fair coin n times, and the number of heads represented by the x. Okay.
Yes, sir.
So you are tossing a coin when you have been
Given n equal to n, sir.
to n, right? So that means given that n equal to n, let's say capital N is 3. That means you have to
I have
toss
to
a
toss
coin
the coin
3
3
times. So
times.
this part is conditioned. This n equal to 3, then you are interested to know the
The
number of
number of
heads,
heads, sir.
and this is going to follow binomial 3 comma half. Is this clear?
Half.
Right.
Yes,
So
sir. Yes,
this
sir.
conditional
Yes,
is
sir.
given to you. All right. So is this clear?
Yes,
So
sir. Yes,
from
sir.
Yes.
Sir, in the equation we are working on small n. We already have it on the LHS and one part of RHS also. So shouldn't we be taking it as n over here also? That's what my
see,
doubt was.
no. You can take. So I'm going to use this n to calculate the
Sir, the
joint.
below equation, sir, I got this equation. This equation I got, but the below one, sir, the last
Which one? This one.
This one, yes, sir.
How can you calculate this part?
We, sir, that is the thing we don't know. But for the f of x of k, we know that we are working on small n. So can't we say that?
No, how you can? So you don't have this one also, right? This is something you have to calculate from the
That's what
question.
I am saying, sir. Shouldn't it be binomial because we are working on small
No.
n? That's what my doubt is.
No,
No, that is not binomial.
It's not
It
binomial.
can't be binomial. It's not following the distribution.
Correct. This is not a binomial, right? Binomial is when this is n equal to 1, then x is
Given
binomial.
condition, sir.
Conditional is binomial, not marginal one.
Marginal.
Okay?
Yes, sir.
Just think a bit, right? Okay. So what we will do, we will use this concept joint equal to marginal joint equal to conditional into marginal, and
So
by using
marginal can't be binomial anytime.
marginal can't. Yeah, that is something we will derive. So don't worry. Okay, that is something. So this will marginal. Let me write in the. So this is conditional into marginal. Okay. So now thing is, conditional is given to us, right? So f(x) given n equal to n, right?
Yes, sir.
Yes, sir.
And this n of n, by using this, we will calculate these two, right? I mean this joint. Now, first of all, what is the distribution of n? It is Poisson, right? So what will the f n of n? This is e raised power minus lambda. Lambda is for n divided by n factorial. And what will the range of n?
N factorial.
0, 1, 2, and so on, right? Yes or no?
Yes.
And what is the distribution of x given n equal to k n? We know this is binomial, right? No, it should. One second. There is a mistake. It should be n equal to n, x equal to k. So this will be n c k. Yes or no? Half
Yes, sir.
power
Yes, sir. Yes.
half raised power n minus
N minus k.
N minus k.
Yes, sir.
this power will be, it will be n choose k half raised power n, right? What is the range of here? What is the range of k? Tell me.
Sir, 0 to k.
0 to k?
0 to n.
No, sir, 0 to n.
0 to n.
Right? Now, let's try to do. So we know this joint part will be equal to fx given n equal to n k, sorry, f n of n, right? So what we have to do? So this basically, this is the conditional part, n c k half raised power n, and what is this?
N.
Marginal. This is e raised power minus lambda. Lambda is power n divided by n factorial, right? Is this
Yes,
clear?
sir.
Now,
Yes, sir. Yes.
we know how we can calculate the marginal fx of k. We know we need to do the summation over the range of capital N, okay, and which is fx n. This is k comma n. Is this clear? And what is the range of what is the support of x? I mean, sorry, range of x. Sorry, not x. N. This
1
is
to 1 to
0 to
0 to
infinity.
N.
infinity.
Basically, I have to do summation of n equal to 0 to infinity, right? So fx of n, k comma n. Just one thing I will ask to all of you, but let me write something. What is this joint? Joint equal to n choose k half raised power n and this part, right?
Yes, sir.
N c k half raised power n e raised power minus lambda raised power n divided by n. Now tell me, it would be right. I will write n equal to 0 to infinity, or I need to change.
Sir, so 0 to k will be no value, sir.
K to infinity.
K to infinity, sir.
Yeah, but why k to infinity? Why should I write k equal to k to infinity?
Cn k will be 0, sir.
Because
0
we are here choosing, sir, k. We means telling 1 or 2, 3 times here k number of times.
Yeah. Okay, so if I will write nc k minus 1, would it be true? Probability will be 0 in that case, right?
Yes,
I mean,
sir.
null
Yes,
event.
Yes.
Yes, sir.
Okay. Are you getting my point? Okay.
Yes, sir.
Yes.
So, okay, now then we need to solve this. Okay. So what else I can take outside? So I can take e raised power minus lambda outside of the summation.
Yes.
Yes or no?
Yes, sir.
This is something. So this is will be nck and okay. So lambda is power n divided by n factorial. Let's try to solve a bit carefully. We need to adjust the
Explaining
term.
this
So
k to infinity.
and this is n equal to k to infinity n factorial k factorial n minus k factorial, right? And then it's a lambda raised power n divided by n factorial into 1 by 2 raised power n, right? So this n factorial will get cancelled out. Yes or no?
Yes, sir.
So this will be
Yes,
raised to
Yes,
power
sir.
lambda summation n is equal to k to infinity. So okay, one thing we have to adjust. Okay, so can I write this lambda raised power n as a lambda raised power k plus n minus k? I mean, I'm just adding k and subtracting k. Can I do?
yes, sir.
Yes,
Yes.
sir.
If I'm able to do this, then can I do lambda raised power k into lambda raised power n minus k?
Yes, sir.
Yes, yes.
And we have k factorial and n minus k factorial. And similarly for this, can I do 2 raised power k into 2 raised power n minus k? Any doubt?
No, sir.
No,
Okay.
No, sir.
No, sir.
Can I take lambda raised power k divided by k factorial into 2 raised power k outside of the summation set, because we are interested only for n, right?
Yes.
Are you getting my point?
Yes, sir.
Right? So far so good. Any doubt?
No, sir.
No, sir.
Okay, all
No,
right.
sir.
So
So this
yeah.
new things introduction, the just above you just did the it's legal, those things are quite confusing.
No, it's legal, right? It's not illegal something, right? So yeah.
Sir,
So
sir,
thing is,
just can you explain n minus 1k? Just confused here.
n
So,
minus.
would you mind explaining the k to infinity once n equal to k to infinity?
Okay, what k represents here?
0
Number of
Trials.
Right.
number of trials or number of head?
Number of heads.
Number
Number
of
of heads.
Heads.
Okay, if okay, is this possible to take k minus 1? Just think a bit. Okay, let me do like this. If I'm saying n nc k minus 1, and we know k is going to from 0 1 to
N.
n, right? Is this okay?
No, because it will be otherwise
No,
minus
sir.
one, the lower it will be.
No, sir.
Right?
We will get
Is this
negative
clear?
number.
It will have -1.
Basically, probability. Okay, probability before when below k will be 0. Are you getting? So for k, when first of all, when n is k, it will be kck, right?
Yes.
Yes.
Are you getting my point?
Yes.
Okay. Now, okay, someone was asking something here. So if I have lambdas for n, so just for adjustments, you can say you can see you have something n minus k here, right? Can I
Yes.
do lambdas for k and lambdas for n minus k? Is this okay? I'm just adding k and subtracting k.
Okay, sir.
Yes,
To,
sir. Yes, sir.
to adjust this k factorial and this n minus k factorial. Okay?
Okay, sir. Got it.
Okay. The similarly, in similar way, can I do for 2 raised power n?
Yes, sir.
Right? Now, you can see summation is for n only, right? So, I will take all the terms related to n inside the summation and remaining term I took outside, right? Is this all right? Now,
Yes, sir.
just see carefully. Can I do lambda by 2 raised power k divided by k factorial? Because I have lambda for k divided by 2 raised power k.
Yes, sir.
And this summation is n is equal to k to infinity. And okay, can I do here
Lambda by 2 to the power n minus k.
n minus k? Yes, same way. Would you agree with me if I will do lambda by 2 raised power n minus k divided by n minus k factorial? Any
Yes,
doubt?
sir. No, sir.
All right.
Yes.
Now, so this is something e raised power minus lambda by 2 raised power k divided by k factorial. Can I write n equal to k to infinity as a n minus k equal to 0 to infinity? Yes or no?
Yes, sir.
N equal to, rather than n equal to k is equal to infinity, can I write n minus k equal to 0 to infinity? See,
Yes.
you n minus k equal to 0, it is same as n equal to k, right?
Yes, sir.
Are you getting my point?
Yes.
Yes, sir.
Yes.
Yes, sir. Yes.
There is something called summation. If summation r equal to 0 to infinity x raised power r divided by r factorial, this is nothing but e raised power x.
X.
Okay.
Yes, sir.
So here you can see you can take n minus k as a r. Okay, if you will take this, it will be r equal to 0 to infinity lambda by 2 raised power x, I mean r, and divided by r factorial. Are you able to relate?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Then what will be this whole terms? Can I write e raised power x? So instead of x, you have lambda by 2.
Yes.
Yes.
Yes, sir.
Correct? It will be e raised power minus lambda by 2 raised power k divided by k factorial. Now, if this is the case, so can I do e raised power minus lambda plus lambda by 2 into lambda by 2 raised power k divided by k factorial? And what will be in the power? This will be e raised power minus lambda by 2 raised power k divided by k factorial.
K factorial.
Okay, this is the distribution of fx of k. Can you relate what is what kind of this distribution is?
Poisson.
Poisson distribution.
Poisson distribution. What is the parameter?
Lambda by 2.
Lambda by 2.
And what will be the range? 0, 1,
0 to
2,
infinity.
0 to infinity.
K. 0 to K.
No. For Poisson distribution, it's 0, 1, 2 till infinity.
Infinity.
Okay.
Okay, is this clear, right? You can see it's very simple. I mean, I agree there are some steps. If you will solve, you will get idea. But don't worry, in the exam we are not going to ask the derivation. I did here just to give you idea how to use, the concept of joint equal to conditional into marginal, and if you want to calculate the marginal, joint is given to you, something like this. Okay, is this all right to all of you? Yes, no?
Yes, sir. Yes,
Yes,
sir.
sir.
Okay, so yeah.
Sir,
Can
excuse me, sir.
yeah.
Okay. Can you show this? I thought of asking to show this. Last one.
This one?
Thank you, sir. You can proceed, sir. Thank you, sir.
Yeah. If you need this PDF, I can share on the portal. That's not a problem. The only thing you are able to understand after this session, because
So sir, from this Poisson distribution result is denoting the joint PMF of this function.
this is marginal.
Marginal PMF of this function. Sorry.
Yes, yes. So marginal means you are talking about a single random variable. Okay. Okay. The since something, let's proceed for joint PMF of more than two random variable. I will take the theory part. Okay. So and then we will. There is something. I mean, just an extension of the concept which we have seen till now. Okay. So next is called joint probability mass function of
So multiple random variable.
more than two random variables. Multiple random variables basically. So I'm writing RV for random variable. So you saw for two random variables, right? So let's say in multiple random variables. Okay, in case of two random variable, let's say x1 and x2, and let's say a range of x1 I'm going to represent with tx1 and range of x2 with tx2. Basically, this is a function, right? If you are talking about joint PMF, this is a function, right? From Cartesian product of these two. I mean, basically tx1 into tx2 to what should be the 0 and 1, right? Because
Yes,
that is
sir.
something range, right? Now, so in case of 2, we saw as fx1, x2, let's say t1 comma t2. What was that? Probability that x1 equal to t1 and x2 equal to t2, right? This is the meaning of joint PMF, right? In case of two random variable, right? If you have three random variable, how will you do? X1, x2, x3, t1, t2, t3. So this t1 for x1, t2 is from range of x2, t3 is from range of x3. This what is the meaning of this? X1 is taking value t1, x2 is taking t2, and x3 is taking t3. Is this all right? So if I will talk about n random variables, x1, x2, let's say till xn, and here it will be t1, t2 till
TN.
tn. So it will become tx equal to t1, x1 equal to t1, x2 equal to t2, and
Till
so
xn
on,
equal to TN.
xn equal to tn. Right. So this is something, right? So you can see. Any doubt here?
No, sir.
So then how would we
Excuse me, sir.
what
Yeah, sir. All these will be dependent or independent or mixed one.
That
Is
yeah,
it?
that will depend on the situation, right? So as of
Okay.
now, we will take the example of independent one. I mean, so that you can connect with the concept. We will once we will move ahead, we will take the another example. Okay.
So
Now,
same formula will be applicable for in both the conditions.
correct.
Right. Yeah. Okay.
What do you
Thank
mean
you.
by same formula? Can you clarify?
Means same concept. Same concept.
Correct. Yes,
For
yes.
joint PMF.
Yeah.
So either will it be the mixture of both? Some are dependent, some are
Yeah,
independent.
that is something we will discuss. Don't worry. Don't worry about those things. So what you have to do? Just follow the things which we are discussing. Okay.
Okay, sir.
Yeah.
Thank you.
Sir, can you explain that Cartesian product of the ranges which you have denoted above?
So that is function. Okay. What from math concept? Can you tell me what is the idea of function? You or anyone which if you would like to explain.
A function maps certain value from a set to another set.
Right. So if I'm talking about two random variables, right? Joint PMF of two random variables, then I should move ahead from this to this, right?
So how did we get that 0,
Because
comma 1?
okay,
That is the issue.
This is all the okay. Let me take one example. If you see in case of when we were tossing a coin twice, right? So what are the possible values? Okay, let me write here. Do not get you confused with the some terms. If you will let me say, suppose you are tossing a coin twice. Okay, let's say this is x1, this is x2. What is the possible values x1 can take? 0 and 1, x2 0 and 1, right? Let's say what is the possible combination? 0 0 0 1 1 0 1 1.
1.
These are all the possible cases, right? If you would like to,
Yes, sir.
if you will find the probability of x1 x2, in this case t1 comma t2, let's say what is this? 1 by 2 into 1 by 2, which is 1 by 4. 1 by 4, again 1 by 4, again 1 by 4.
Yes, sir.
Here what you are doing, you are considering all the possible cases of the range, I mean all the possible cases of when x, all the possible values of random variable x1 and all the possible values of the random variable x2. Okay, and this is output is will be only from 0 to 1, right? It can't exceed 0 and 1, right? Because this is a probability.
Okay, sir. Got it, sir. Actually, I thought you were denoting something else.
No,
Now
no,
I
no,
get
no,
that
no, no.
you were denoting the function.
Okay, okay. If you're getting confused with Cartesian product or
No,
something,
fine, sir.
don't
No,
go with the technical word.
It's
So
fine,
just
sir.
okay. Now it's clear, right?
Yes, yes.
So if because we are going to discuss about more than 2 random variables. Suppose I'm saying toss a fair coin. Let's say thrice, or you can say toss a 3 fair coins once. Anything, right? So let's say I'm saying xi will take value 1 when if ith toss is head, and xi will take value 0 if ith toss is tail. Is this clear? Okay, and what is the possible values of I? 1, 2 and 3, because I'm talking about only I'm going to toss a coin 3 times. Yes or no?
Yes, sir.
Okay. So
Excuse
what
me,
is
sir.
yes?
So it can take value 0 also, no?
Okay, just try to think. Okay, do not here what I'm saying. What is the xi? Xi represents the outcome of the ith toss, right?
Okay, okay.
Okay, so I'm interested in the ith toss. So here xi, basically you can think like this. So x1 represents the outcome of first toss. X2 will represent when you are going to toss a coin second time. X3 will represent when you are going to toss a coin 3 times. In each case, it can take 0 or 1, 0 or 1, 0 or 1. Yes or no?
Yes, sir. Yes, sir.
Basically, what is the tx1? It's a 0, 1.
0 or 1.
Same as tx2 and same as tx3. I mean, ranges of x. So what you have to do basically, so whenever you have to calculate joint PMF of, two random variable, more than two random variables, it's good to go with all the possible values, because in that case there is very less probability of making mistake. Okay, it may take some time, but you are not going to make a mistake. Okay, so let's say x1, x2, x3, this is the joint probabilities. Now what are the possible cases? Okay, do let me know if I miss any cases. So first of all, this is possible 0, 0, 0, right? This means in all cases you got tail, right? In all tosses. Then 0,
Sir,
0, 1.
total number of cases are 8, na?
We'll see. Okay, don't worry. Total will be 8. That's not wrong. I'm just thinking to all the possible cases. Okay, so 0, 0, 1. It can be 0, 1, 0. Basically, you can fix first 0 and then you can interchange, right? 1, 1. Are you getting my point?
Yes,
And then next will be 1, 0, 0. Then 1, 0, 1, 1, 1, 0, and 1, 1.
1, 1, 1.
So, okay, you can think in two different approach. First of all, you have total how many? Okay, what is the probability? Probability is favorable cases divided by total cases, right? What is
Total
the
cases.
case is 8, and this is the for getting this part. This is 1 by 8.
Yes, sir.
Or else you can think like this. So for 0, this is 1 by 2, 1 by 2, 1 by 2. So 1 by 2 into 1 by 2 into 1 by 2, which is 1 by 8 again. Okay. So that is something I'm applying the concept of independence. Is this clear?
Yes.
So for each case, it will be 1 by 8, right? 1 by 8, 1 by 8, 1 by 8, 1 by 8, 1 by 8. Any doubt? So you can see we got the what to say, this joint probabilities of more than 2 random variables. Okay, so there is something, if I will ask you to calculate, tell me fx1, x2, x3, tell me the for basically let's say t1, t2, comma 0. Then what do you mean by this case? What you will do?
T3 is 0.
0.
T3 0, 0 is fixed. You have to add all the when T3 0 and all the
T1 and T2 can be varied.
correct. Basically, you have to add this row, this one, and this one, and this one. Yes or no?
Yes, sir.
Would you agree with me? Right?
Yes, sir. Yes.
So basically it will be 4 by 8, right?
1 by
Or 1 by 2. Okay. If so, I mean, there are lots of things you can calculate. So if I will ask fx1, x2, x3, let's say t1, comma 0, comma 1. This, okay, tell me what is the meaning of this part?
T1 is a variable.
T1 is going to vary.
T1 is variable, T2, T3 is fixed.
Okay, so when T2 is 0 and T1 is, sorry,
One.
T3 is 1, right?
Yeah.
And T1 can vary. That means we have to add
2 by 8, sir.
this part and this part. These are the only two cases, right? So
2
this
by
is
8.
2 by 8, right? Or you can say 1 by 4. Is it clear how we are proceeding, right?
Yes.
Yeah.
Yes, sir.
Yes, sir.
Yeah.
Okay. So if okay, in case of two random variables, okay. First of all, if I will ask fx1 of 0, what do you mean by this?
0 is fixed.
Marginal, sir.
Okay, this
X1
means
in X1, 0 is fixed.
okay. Let's try to understand. So 0 is fixed. Another rest things are varying, right? Basically, let me use some different color. Let's say blue one. 0 is fixed, right? You have to add this plus, I mean, this highlighted one, right? Only this part.
So 4 by 8 is the answer.
Okay. Don't worry about 4 by 8. So what I'm trying to explain here,
Okay.
this means what you are doing, fx1, x2, x3, 0, 0, 0, right? Plus
Yes, sir.
fx1, x2, x3, 0, 0, 1 plus fx1, x2, x3, 0, 1, 0 plus fx1, x2, x3, 0, 1, 1. Okay, that is something we are doing. Can you tell me what is the technical term? What is the technical term? The thing which we are doing here?
Marginalization, sir.
Marginalization. Correct. Very good.
Marginalization.
So I did fx of x1 of 0. If I will ask fx1 of 1, then you will add all these 4 cases? Yes or no? These
Yes,
4
sir.
cases.
Yes, sir. Yes.
Yes, sir. Of
Right?
course, of
So,
course.
okay, what you are doing here to calculate the marginal, you are adding all the possibilities. I mean, you are adding for those for all those cases when x2 and x3 are varying. Yes or no?
Yes, sir.
So,
Yes, sir.
that means if I would like I would like to write in simple terms, in general terms, then let's say this is t1, then what you will do, this means we have to do the summation over t2,
T2 belongs to
let's say
T.
comma x2, and t3,
T3 belongs to X3.
so x1, x2 and x3, this t1 comma t2 comma t3. Would you agree with me? Is
Yes,
the
sir.
meaning of notation clear
Yes,
to
sir.
all of you? So you can see what we are doing to calculate the marginal of x1. We have to do the summation for another two random variables. Okay.
Yes, sir.
So
Yes, sir.
if we have to calculate fx2 of 0 for a particular case, then what you will do? Basically, x2 is 0 is fixed. Okay. Let me use some other color. Which one can make the difference? Let's say this.
So this is basically the marginal one, right?
Marginal one. Yeah, that's I'm trying to explain to you, right? How to relate. So this you can see x2 is 0. This is fixed. This is
This
fixed.
is fixed.
This is fixed. This is fixed. So you can see 0 is fixed. You are adding for other cases. I mean, anyway, it's a 1 by 2. That's not a. I mean, we are not worrying about the final answer. The thing which I'm trying to explain, whenever you have to calculate the marginal, what you have to do, you have to add the joint with this will be t2 for the other with respect to other random variable in general. So this will be tx1 and t3, tx3, and this joint. Is the notation clear to all of you? Any doubt?
No, sir.
No, sir.
So if I should write for x3, if I will write for x3, then what it will be? It will be for t1 and
T2.
you will add t2, right?
T2.
Okay, so I think it's clear to all of you, right?
Yes, sir.
Okay. This meaning of the notation. One more thing, if you can think a bit. So this is marginal. You can say marginalization. So if you will add, okay, what is this? This all probability 4 by 8. That is 1 by 2. Again, you will get 1 by 2. Yes or no?
Yes,
For
sir.
fx0, fx1, 0, fx1. The
Yes.
case if I will add fx1 0 plus fx1 of 1, what is this? This is
1.
right?
1.
So this is the marginal PMF of x1. So basically you can see x1 is taking value 0 and 1, and we saw fx1 of t1. So for 0, when fx1 is 0, let's say for 0, and this is fx1 of 1, we got 1 by 2, 1 by 2. So this is not joint, marginal PMF of x1. Is this clear?
Yes,
Okay.
sir.
If
Yes,
someone will
sir.
ask you,
Yes, sir.
some joint PMF is given to you, and suppose question is you have to calculate the marginal. Will you able to calculate? Yes, no?
Yes,
Yes,
sir.
sir. We will be able to
Yes, sir.
calculate.
Yes, sir.
Okay, then it's very good if you are able to uh, calculate the things, because it's a very good thing. And can you calculate the joint also? I mean joint PMF. So what I mean by joint, if I will ask what is the fx1 x2 0 comma 0, this means
Yes.
what? What you have to do? These two things are fixed. You have to do for third random variable, right? So what I'm saying,
Yes, sir.
x1 and x2 are at 0 is fixed, right? This means
Yes.
this case is fixed, right?
Yes.
And this case is only these two are right.
2 by 8, 1 by 4.
Yeah, 2 by 8. That's final answer. So what I'm trying to
1 by
explain,
4.
this is the only case, right? These two are. So
Yes,
what
sir.
you are doing, you are adding with respect to the third random variable, right?
Yes,
Are you
sir.
getting my point? So this means what you are
Yes, sir.
doing,
Yes, sir.
basically this means x1 is 0, x2 is 0. To calculate this, what you will do, x1 is 0, x2 is 0, you will add for x3 is equal to 0, and when x3 is 1. So you can see what we are doing, summation over the joint, the joint PMF of all these three random variables. Since I'm interested only in two random variables, then what I will do, I will do the summation over the third.
T3 belongs to TX3.
Is this clear? If
Yes,
Yes,
sir.
sir.
Yes, sir.
if the question is about x1, x3, 0 comma 1, whatever. Okay, here since I'm writing in general, I should write t1 comma t2. So I will write t1 comma t3. Then what summation will be for what?
For T2.
For t2. Right? Okay, is this clear, right? If I will, if I'm interested to
sir.
calculate fx2 and 3,
X1.
x1, right?
Summation T1.
Oh, very good.
T1.
Very good.
Sir,
Very
can
good.
you explain one question, sir?
Yeah, so we
So,
can go with this. So if I'm saying, yeah, YouTube link I have updated on the calendar, Vaisali. You can go on the calendar. If you will click on today's calendar, so YouTube link is there. Okay, we will maintain a seat and we'll upload on the portal, but it will be done by like tomorrow. Okay, you can access from the here YouTube link from the calendar only. Yeah, yeah. So suppose my
Sir, can
question.
you explain one question, sir?
Yeah. So see, so from here, if I will ask, okay, let me write the all those things. I think I have to come. This is T1, T2, T3. Just ignore this. This is the page number. So this is 0, 0, 0. And what was the case? It was. Let me write 0, 0, 1, and then what else? Yeah, tell me. Think a bit.
0, 1,
0, 1,
0,
0.
0, 1, 0.
0, 1,
0,
1,
2.
0, 1, 1.
1, 1, 1.
1, 0, 0. 1,
1, 0,
0, 1.
1.
1, 1.
1,
1, 1.
1, 1, 1.
If you will write randomly, then you will get confused. So just fix 1, 1, 2, change third one. 2
Yeah.
fix, change third one. Right? Then you will get. Okay. So suppose question is you have to calculate fx1. I'm not writing the margin. I'm just suppose I'm into fx1 x2. Let's say 0 comma 1. So what you have to do? X1 is 0 and x2 is 1. Basically, you have to add this case and this case.
Yes, sir.
Yes or no?
Yes, sir.
Yes,
So
sir.
basically, it will
Yes,
be
sir.
1 by 8 and 1 by 8. So basically, if you go with the notation, so this is fx1, x2, x3, 0, 1, 0 plus fx1, x2, x3, 0, 1, 1. So this means probability in this case, and you have to add probability in this case. So which is basically 1 by 8 plus 1 by 8. So which is 2 by 8, or you can say 1 by 4. Okay. So if I will ask, let's say fx1, x3, let's say 1 comma 0. Tell me which. Okay. Okay. Don't worry about this. Tell me in terms of notation, what should I write? fx1, x2, x3. Tell me in the bracket, what should I write? 1,
1,
0, comma 1, 0, right? Because x1 is going to take 1 and x3 is 0, plus fx1, x2, x3. So basically, you can do like this.
1, 0.
Correct.
That's
So,
it.
yeah, you can think like this. So whenever you have been given question like this, the very basic approach is x1 is fixed as a 1, x3 is 0. So you can just fix x3 as 0, and just think what are the possible cases for x2. So here 0 and 1. So there is another possibilities also, right? I mean, it can be 0, 1, 2 or something else. So just write what are the fixed and
so this one also falls in marginal only, right?
No, it's not
Fine.
a it's a joint of x1 and x2. Marginal means you are
Single.
talking about only one random variable.
One variable. Okay.
Okay.
The
So this
moment
is
it becomes 2 or 3, it becomes joint basically.
Correct.
One, yeah.
Because joint is, I'm interested in more than one, right? If
Right,
I'm talking about only one, this is a marginal. So why this is called joint? So because here you can see, initially we have the probability for 3 random variables, right? From 3, we are moving to 2. Again, 2 is joint probability mass function, because I'm interested at the 2 particular joint values, right? Yes? No? All right?
Sir.
So this
It is
marginal.
It's joint marginal.
No, it's not joint margin. It's just a joint. You can't say marginal. So marginal is, I can say in very simple terms, marginal means I'm talking about a single random variable. Okay.
Okay.
If you want to do the conditional thing, right? So here, if you want to do conditional thing, we have seen. So tell me if I would like to write fx2 x3 equal to 0, 0. This means what?
F of x2
x2
equal to
x3
0.
0 comma 0 divided by fx3 0, right? So this means what? You have to calculate this joint, right? And this margin only, then you can find, right? So let's try to understand. So fx2 x3 0 comma 0, how you can calculate? When you can calculate fx1 x2 x3 when x is 0 plus fx1 x2 x3, just fix x2 x3 0, right? These two cases, yes or no?
Yes, sir. Yes, sir. Yes.
This is 1 by 8 plus 1 by 8, which is 2 by 8, 1 by 4, right? And fx3 of 0 means what?
1 by 8.
x1, x2, x3. You can see this is 0, right? So it can vary 0 and 1. Let's say 0, 0, 0. Then fx1, x2, x3. You have to add all possible cases when x3 0, all are varying, right? So it can be 0 and 1. Are you getting my point? fx1,
Yes, sir, got
x2,
it.
x3.
Yes, sir.
It can be 1, 0, 0. fx1, x2, x3. It can be 1, 1, 0.
1, 1, 0. Yes, sir.
All cases are done, right? So this
Yeah.
is 1 by 8. It's 1 by 2, right?
Yes,
So
sir.
what you have to do? You did this as a 1 by 4. You did as a 1 by 2, and just calculated whatever the possible answer. So you can see if you have been asked to calculate this case, then just apply the conditional probability formula and go with this. Since you don't know this, but you know to calculate the value of x2 and x3, I mean joint PMF of x2 x3 in case of third, then what you have to do? You have to do the summation over all the possible values of the another random variable. Okay, any doubt? If I will ask f x1 given x2 equal to 0, let's say x3 equal to 0 and 1. This means what? I have to, this will be in the numerator part, it will be 1, 0, 0 divided by fx2 x3 0 comma 0. Yes or no? Because this is given, right?
Yes.
And this part we have calculated here in the numerator, I mean in the above part. Are you getting?
Yes, sir.
Right?
Yes,
And
yes, sir.
this is nothing but from the table you can see this is anyway it is going to be 1 by 8. and this is 2 by 8.
Sir, two conditions also can be given, sir.
Sorry.
Can two condition given x2 and x3 simultaneously can be given in the
I
condition?
mean, you are saying x1 given x2 given x3.
I'm saying x2 and x3 both 0 can be given at a single time.
No, I'm not getting you. So
I'm asking you, when we say y is equal to x1, and now we are saying x2 is 0 and x3 is 0. The two given condition also can be taken.
yeah, it's possible, right? This is possible.
Okay.
So this is just treat this as a b. Just treat as this is a. So in the denominator, this is probability of b, right? And we know this is probability of b. What is this? Now you have to think what is the meaning of this. So now this is joint of probability of x2 and x3 when x2 and x3 both are taking value 0. And this is something we have calculated from the above. Just a difference of notations. Okay? Okay. All right. Yeah. Okay. I think math session is started or it's about to start.
Yeah, sir. It will just.
Yeah. So actually,
Yes, sir, it started.
yeah. So we are actually we are. I'm done with the concepts of week 1 actually. Okay. Okay. So if you want, we can wind up. If you want to attend the math, is this first session or second or something?
Instructor session is the
Third session.
First session.
Third session, sir.
Third.
Actually, they will tell week 2, sir. Week 2 maths.
Yes, sir. Week 2
Yes, sir.
All right. Actually, we didn't started initially because there was something week 0 also, right? So we gave time to you to just do a brush up on week 0. So week 0 is just nothing but just you can say revision of concepts of week stats 1 course. Okay, there are some additional point. Don't worry about questions from week 0 in exam, but
Is that necessary,
actually in
sir?
the chat, Sanwa, this is not possible. I mean, in Gmeet chat, we can't paste the PDF link. I will share with the team. They will upload under the supplementary content. Okay, don't worry, but it will be available by tomorrow only. Because
Sir, is that necessary to attend or see the lecture of week 0?
Sir, or you can paste the link on calendar now.
Okay, I will do. See, it's not. See, I will not say it's a compulsory. If you are okay, if you feel you are more confident on stats 1 concept, or else you are able to connect with the week 1 concept, then it's fine, right? So
Sir,
week 0.
in the next session, solve with us. You can solve. You can give a brief of week 0 and solve the practice assignments.
No. So see, we are not going to see week 0 is just for yourself. Okay. So week 0 summary is bit tough in doing in a session, right? So that's why we have mentioned as a week 0, not compulsory week. There
Yes,
is
sir. That's
no graded assignment in week 0. Week 0 is something whenever you feel you are not able to recall the concept from stats 1 concept. Let's say we discuss the Poisson distribution or PMF or conditional of a single random variable, right? Then you can go through that. Okay. So whenever you feel you have time, just go through that. Okay. So
it's like revision, sir. It's like revision when we don't have.
Correct. Okay. Okay, then if you have to attend the math session, then we are done with the week 1 concept. So what we will do in next session, we will solve the questions from the slides. Okay, I will present some slides, and we will try to me or some other instructor like as per the availability, we will conduct the session. Okay. So I hope you got something from this last 2 hours. Last 2 hours.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. Thanks all of you.
Sir.
Nice.
Thank you, sir.
Thank you, sir.
Sir, there's a doubt in last equation. Sir.
Which question?
The last equation.
Okay, so which we were discussing?
Yes, sir.
Okay, let me share my screen.
It's just a matter of syntax, sir. I'm a bit confused in syntax.
Which syntax?
So the last equation. You have written f of x1 given x2 is equal to 0 and x3 x3 is
Correct.
equal to 0.
Correct.
If there is an equation f of x1 equal to 0, comma x2 is equal to 0, given x3 is equal to 0, how would we interpret
Okay.
it?
Okay. So you are saying fx1 equal to 0, x2 equal to 0. Basically, you can write like this, or okay, let me write in different form. I mean, I got your idea. So x1, x2, you are saying x3 equal to 0, right? And here 0 comma 0, correct?
Yes, sir.
This means x1 is taking value 0. So what is the meaning of this? Just give me a minute. Just give me a minute. Okay, so what is the meaning of this? So this means probability that given that x3 is taking value 0, and what is the probability of x1 will take value 0 and x2 will take value 0? Is this meaning okay?
Yes.
Right, this is the meaning, right? So I'm saying it is given that x3 is going to take value 0. What is the probability that x1 will take 0 and x2 will take 0? All right. So now if you will apply the conditional probability formula. So what is this? Probability of A given B is nothing but probability of A intersection B divided by probability of B.
Yes, sir.
All right. So this is something you can treat as a A. You can treat this as a B.
Yes,
so
sir. Yes, sir. Got it, sir.
Right, so it will be x1 0, x2 0, and x3 0.
Yes, sir.
Divided by probability that x3 equal to 0.
Yes, sir. Got your point, sir.
Okay.
Yes,
Oh,
sir. Yes, sir.
yeah.
Thank you, sir.
Yeah, thank you.
Sir,
Oh,
I have a question,
I have
sir.
a question, sir.
Mm-hmm.
Sir, will you also help us with the graded assignment questions in the next session?
See, graded is something which you have to try on your own. I can give you idea, but we can't solve the question before the due date. Okay, this is something you have to try on your own. Okay, let me clear one more thing. The next session, which is going to happen on Tuesday, in that session we are going to solve the questions. So I will present some slide, and we will discuss some questions, and those questions are somewhat similar to your graded assignment. I mean, you will get some sort of idea to solve your graded assignment. See, if you have any question related doubt or something, we can discuss, but if you want to solve question before the due date, so we can't. Okay, that is something you have to do. Okay.
Sure, sir. Sure, sir.
Okay.
Thank you.
Yeah.
Thank you,
Okay.
sir.
Yeah. Yeah.
Thank
Yes,
you,
sir. Okay. Okay. All right then. Thank you. Thank you all. Bye bye.